Okay, so we're on page 10. We're not going to get very far into it, but at least we can kind of split this up into 2 days. Okay, so we're on page 10 of your packet. This is 2.05. Graphing sine and cosine functions. We talked about amplitude. We talked about that deals with the a value. We talked about the b value, which is going to end up shrinking or compressing or extending your period value. But today we're talking about what's going to happen if we were to shift the graph left and right. And we're going to talk about the c value here. So any value that is being added or subtracted with the inside or with the theta measure that's inside the sine or cosine, that's going to do the job of shifting the graph left or right from the parent graph. Okay, so let me read this here. Phase shift is a horizontal shift. That c tells us the phase shift and the direction is opposite of what you would expect. And the reason why we say that is because normally, if you think about the x-axis, right, we associate moving right with positive and left with negative. But anything inside next to the theta is going to be opposite. So if you see a minus value, that means it's going to move to the right. If you see a positive, it's going to move to the left. So everything is kind of backwards than what you would expect. And here is what we also want to do is if the expression doesn't have the b value factored out, we're going to do the work to factor that b value. And the reason why we do that is because we're going to be able to limit the amount of additional formulas we have to memorize. Okay, so if we can do the work of factoring the b out, then whatever you see here is going to be your phase shift. There's no need to do any, there is an additional formula if it's not in that form. So we're going to try to limit the amount of formulas we have to memorize just to the ones we absolutely have to. Okay, so example 1 here. Identify the transformation that occur on the parent graph and the graph of the function. Okay, so if we look, let me zoom in here. If you look at number 1, what's the a value? 1, right? Doesn't change. What's the b value? Still a 1. Okay. The only thing that is changing is this minus 3 power 4. So this is going to either shift the graph left or right, but we see a negative here, so it's going to shift in which direction? To the right. Yeah, so negative is right, positive is left. It's opposite, okay, with what you would expect. Okay, so we'll go ahead and write that. So we're going to say that the graph by 3 pi over 4 units. Okay, so that's the only transformation off of the parent graph y equals sine theta. Now, number 2, y equals cosine of 2 theta plus pi. What's the a value? 1. What's the b value? 2. Now, here's the thing. The 2 is the b value, but it is not in the place that is helpful or the most beneficial for us when we are ready to figure out what the phase shift is. So we're gonna try to get into a habit or practice of getting that b value to be cleanly outside both the theta and the pi. Okay, so this is how we're going to do it. We're going to write it as y equals cosine. Okay, and I like to use brackets and parentheses to kind of help, so it doesn't having 2 sets of parentheses just makes it look a little messier. So I'm going to use bracket, and I want to factor a 2 out of the rest of this expression. Now, it's not going to impact the theta because the theta, if I factor a 2 out of 2 theta, then I'm just left with just theta. So there's no issue there. The issue is with that pi. Now, I'm taking a 2 out of 2 theta, so there's no issues. I'm just left with just theta. But I want to take a 2 out of pi. Pi doesn't have a 2 to give, so we need to balance it out with a 2 in the denominator. So I'm going to say plus pi over 2. Okay, it seems kind of strange doing this, But this is something that you can do to always make sure that you're on the right track. If I distribute this through, I should be able to make my way back to my starting point. Okay, so if I distribute 2 through, 2 times theta is 2 theta, that's good. What's 2 times pi over 2? 2 pi over 2, which is pi. So I haven't changed anything, but I've made it so that if I factor that 2 out, then what I'm staring at inside the parentheses is exactly the phase shift. There's no additional formula that we would otherwise have to do with the phase shift. So if there's no number to give, then you're always going to balance it out in the opposite location, in either the numerator or denominator, depending on where this b value is located. Okay, so we said that our a value is 1, our b value is 2, and this is our c value here. Now that b value of 2 is going to end up changing the period or the cycle of our problem, right? So we'll just do a quick evaluation here. Period is going to be 2 pi over our b value, which is going to be pi. So that's going to shrink our period by a factor of pi, or sorry, by a factor of 2. Oops, sorry. Now, we can look at that pi over 2, and this pi over 2 is going to tell us exactly whether it's shifting left or right. So what would you say?
Left.
Yeah, shift left because of that plus sign. So shift left by pi over 2 units. Mm-hmm. Yeah. Okay. Any questions so far? Yeah. So next, we want to be able to gather information and put it into an equation like how we did on the quiz. So number 1 is familiar. We don't have any changes with phase shift. So if we do this here, amplitude is 3.5, period is 14 pi. We go through our formula and we can find our b value. So period is equal to 2 pi over b. Cross multiply. Divide both sides by 14 pi. Yeah, 1 over 7. The pi's cancel out. 2 over 14 reduces to be just 1 over 7. Our a value is 3.5, or plus or minus 3.5. So we can write our equation. This is a sine. We want a sine function. You can either write it as theta over 7 or 1/7 theta. Either way. Okay, so nothing new here with number 1. Okay, number 2, amplitude period, and then we also have a phase shift to the right by 1/2. Okay, so we're going to add that c value into our equation when we're done with a and b. Okay, amplitude is 1/2. That's our a value. Period is 1/3. We can use that to help us find our b value. Cross multiply. I can solve for b. Two times 3 is 6. Okay, it seems strange looking at the b value with pi involved, but that's because the period doesn't have pi to begin with. So when we go through this formula, it just ends up being part of the b value. So okay, so here's our equation: y equals 1/2 plus or minus 1/2. Okay, there's phase shift involved, so let's make sure that we have the bracket and parentheses in place. Bracket with the b cleanly outside a set of parentheses. And now we can involve the theta and the phase shift. So theta We want to shift to the right 1/2. So what can we put after this? Good, minus, right? Everything is opposite, so minus half. This is in the correct form, so we don't have to make any adjustments. As long as our b is cleanly outside a set of parentheses, then your phase shift and this number will always match. We just have to watch out for the sign. Okay, let's see if we can get through number 3 and 4. Okay. Okay, amplitude 1.25, period is 6 pi, phase shift to the right 3 pi. We haven't talked about this. This is shifting up or down, shifting vertical. That deals with this plus or minus d. Okay, but this this value outside is going to be more intuitive because if it's positive value, it's going to be going up. If it's negative, it's going to go down. So you don't have to worry about getting confused with the vertical motion. It's the plus or minus inside the parentheses. I think that shifting left and right, that's what's opposite. Okay, so let's go ahead and find our b value again. Cross multiply. Divide both sides by 6 pi. Pi's cancel out. B value equals 1/3. Okay, I think we have everything that we need to build our equation. Now it's the cosine. So put the 1.25 first. Okay, there's phase shift, which means that we want to make sure that we have a bracket, get that b value to be cleanly outside a set of parentheses. Okay, phase shift to the right 3 pi, minus. And in any motion vertical, it's going to be cleanly outside by itself, no parentheses, no bracket influencing it. Down is going to be negative, so we're going to just say minus 3. Okay, we're not going to do a whole lot with vertical shifts. We're going to make sure that when we graph that we get really comfortable with the phase shift left and right, and then our final element after a few days is to work in that vertical shift. Okay, any questions with number 3? Okay, one last one. Can you guys try this one? Oh, I left out the phase shift. It should be phase shift left 2 units. Okay, can you guys try this for a minute, and then I'll follow up with the steps. Okay, check your number 4. Any questions here? All right, we start with our formula, we cross multiply, we solve for b. Once we insert our b value, make sure it's cleanly outside a set of parentheses. shift left 2 units, so that's going to be a +2. No vertical shift, so nothing, no numbers outside here. Okay, so tomorrow we're going to see how the shift left and right is going to impact the way that we sketch our graph. Okay, so we're just going to focus on that tomorrow. Okay, okay, no homework tonight. We will pick up tomorrow where we left off.